Welcome to what I hope will be a short little introduction or overview of bonding. There are 5 main types of bonding that are typically covered at a high school or early college level course. Typically 10th grade will cover the first 3, and AP, IB, or general chemistry in college will ultimately cover all 5 of them. So watch as much or as little as you need for your learning. Now, the first one is ionic bonding. In ionic bonding, we actually have an exchange of electrons. And in electron world, we like to say metals are losers. They have a tendency to want to donate or give away electrons, and nonmetals are the winners. In an ionic bond, it's the nonmetals that are gaining electrons. So in this example, we have the sodium metal with a 0 oxidation state going to sodium ion when it gave that electron to chlorine. And now it has a +1 charge or oxidation state. Chlorine gains an electron. So this is a loss of electrons, 1 electron. This is a gain of 1 electron. It's tough because you're gaining and losing negative numbers. So you might want to think of a number line and ask yourself, is it more negative or less negative? Since you're gaining and losing negatives. Less negative make positive ions. More negative make negative ions because you're gaining and losing those negative electrons. Okay, so now what we have is we have a positive ion and a negative ion, and when you have a positive charge and a negative charge, we have an electrostatic attraction between charges. And we end up making a positive cation. The word implies what it is, C, a positive ion, electrostatically attracted to a negative ion, an anion. Okay, so that is just the basics of ionic bonding. We're going to delve into each of these in much more detail in other videos. Now, in covalent bonding, the electrons are shared. So the valence electrons, and by the way, remember it's the valence electrons that are involved in bonding. You might have learned this in your atom unit. Valence electrons are your outer S and P electrons. So in this case, the valence electrons on one atom are attracted to the nucleus of another and vice versa. So they're shared. Now, each element contributes electrons to the bonds in this case, bond or bonds, and sometimes they are shared evenly, and sometimes that sharing is uneven. So in uneven sharing, an example is that bond between hydrogen and oxygen in water. In this case, oxygen has a greater attraction for those electrons, and so they spend a little more time. If I could draw an image of the average time spent, they spend a little more time on the oxygen, but they're not totally donated to the oxygen. Okay, so that's one of the things we want to talk about, because that even and uneven sharing gives rise to very different functions. Structure determines function. So if we talk about structure, if we change structure, our structure that we have will help determine and help us predict its function. Okay, so that's the basics of covalent. Remember, this is just an introduction. Now, let's take a look at the next one that is commonly taught at the high school level, and that's metallic bonding. In metallic bonding, what we have is we end up with a positive cation, a metal ion, and then the valence electrons are free to move. amongst ion to ion. I like to think of it as kind of a commune. The electrons play at everybody's house. So they can move freely, and if we have free movement of electrons, we have conductivity. That's why metals conduct, because they have freely moving electrons. And those electrons form kind of a buffer zone so that the positive ions aren't repelled by one another. Remember, positives repel positives. Well, these electrons that are moving around, freely moving, we say they are delocalized, not fixed to a particular location. That those electrons prevent that positive silver from being repelled by that positive silver. It's a fairly rigid structure. Of course, it depends on the nature of the metal. And we call this the sea of electrons model, because the electrons are freely moving as if it's a sea, as if water is kind of moving in and out. So we call that a sea of electrons. Now, the structures can actually get rather complicated, but you typically won't talk about exact structures, rather properties based on that freely moving or delocalized electrons. Now, the next one that I want to talk about that is quite important in upper level is network covalent. In network covalent, you have sharing of electrons. So in this case, you have single, in this case, these are all carbon, and they are called allotropes. Same element, different structure. So we have different allotropes. Sometimes there's double bonds. It depends on the structure. But the point is, it's an ongoing array. It's not a discrete unit like water is shared electrons. That line that I'm drawing is an indicator that we have two electrons forming that bond between the oxygen and the hydrogen. And it stops there. It's a discrete specific molecule with exactly two hydrogens and one oxygen. In network covalent, these covalent bonds go on and on and on in different structures. Okay, this is but this is graphite, this is diamond, we have all sorts of fullerenes, and they're very, very strong. So we have an ongoing array of repeating covalent bonds rather than a specific number of covalent bonds. Okay, and then finally, what you may see in a more advanced class are something called coordinate covalent bonds. Sometimes they're called dative bonds. I like coordinate covalent, but I know I've seen that word in IB before. We have sharing of electrons. So why do we need a new classification? In this example, both electrons are contributed by one of the elements. In this case, if I could color code it, let's do this. I have a hydrogen, it donated one. This hydrogen donated one to the bond, and then the oxygen donated one to each bond. In our example here, let me draw it a little bigger, at least zoom in on that nitrogen. That nitrogen is donating both bonds to form a covalent bond between the nitrogen and the boron. It's donating both electrons to form the bond. So instead of boron bringing an electron and nitrogen bringing an electron, nitrogen was extraordinarily generous, and nitrogen brought both electrons along. Okay, so that's the 5 main types of bonding that you will come across. And in my future videos, or in my next set of videos, I'm going to be going into these in a little bit more detail. So I hope you can join me then. Thanks for joining me today.